Dear students, today we shall be talking about something which could be optional learning for you. Well, if anyone is having some curiosity about why a diamagnetic material develops some opposing magnetic field within it whenever it is brought in some external magnetic field, and otherwise it is having no magnetism. So let us try to understand why this happens. Well, a diamagnetic material is essentially having all paired electrons, means no two electron can have all same magnetic quantum number. So that means the two electrons will essentially have some opposite spin. Now, in absence of external magnetic field, what happens? The net magnetism produced by these two electrons, paired electrons, cancel each other. But the moment some external magnetic field is brought to influence them, the anti-clockwise electron, which is having anti-clockwise motion, spin motion, will experience some Lorentz force which is radially outward, and as a result it will slow down the spin motion of that electron, which causes reduction in magnetic dipole moment produced by that electron. And contrary to that, the electron which is having clockwise motion will experience a Lorentz force which is radially inward, and that means the centripetal force increases in this case, and so the velocity, the spin velocity increases, and as a result the magnetic dipole moment produced by this electron is increased by the same amount by which that has decreased in case of electron having anticlockwise motion. So that means while the magnetic dipole moment of produced by one electron is decreasing, which is having a magnetic dipole moment in one particular direction, say for example we are talking about it in figure 1. Now we have taken that the magnetic dipole moment due to the spinning motion of electron is vertically downward, and that is reduced by a factor delta m when it is brought in some external magnetic field. But in case of the electron which is having clockwise motion, the Lorentz force is acting on this electron is radially inward. That means the centripetal force increases, and which increases the spin velocity of the electron, and as a result the magnetic dipole moment produced due to it is increased. But remember that the magnetic dipole moment produced due to clockwise electron and that due to anticlockwise electron, both are in opposite direction and were cancelling each other when they were not having any external magnetic field around it. But now in the presence of external magnetic field, the resultant magnetic dipole moment becomes non-zero, and it is such that it always opposes the external magnetic field. So students, this is how we can understand that why a diamagnetic material develops an opposing magnetic field when it is brought in external magnetic field, and otherwise it is having net magnetic dipole moment. Thank you and have a nice day.